Remote Access VPN. Remote Access VPN is the most common type most people encounter without even realizing it. It connects an individual user to a private network from a remote location, encrypting all traffic between that device and the network. Companies use it so employees can securely access internal systems from home or while traveling. When you connect, your device essentially becomes part of that private network, even though you might be sitting in a coffee shop thousands of miles away. It became especially widespread during the shift to remote work, when millions of people suddenly needed secure access to office systems from personal devices. Site-to-Site VPN. Site-to-Site VPN connects entire networks to each other rather than individual users. Instead of one person connecting to a company's server, two office locations connect their entire local networks together over an encrypted tunnel. A company with headquarters in London and a branch office in Tokyo can share internal resources as if they were on the same floor. This type runs in the background automatically, with no manual connection required from employees. It is the backbone of how large organizations maintain consistent, secure communication across multiple physical locations. SSL VPN. SSL VPN uses the same encryption technology that secures websites to create its tunnel. Unlike older VPN types that require dedicated client software, SSL VPN typically runs through a standard web browser, making it far easier to deploy. A user visits a secure web portal, logs in, and gains access to internal applications without installing anything extra. This made it popular in environments where IT teams needed to give contractors or temporary workers access quickly. The reliance on widely supported browser technology also means it works on almost any device without compatibility issues. IPsec VPN. IPsec VPN works at the network layer, meaning it encrypts data at a lower level than most other types. It operates by authenticating and encrypting each individual packet of data traveling across the connection rather than just wrapping the session in a single tunnel. This makes it extremely reliable and difficult to compromise. Many enterprise-grade systems and government networks favor IPsec because of how deeply it integrates with network infrastructure. It often works alongside other protocols, and many modern site-to-site setups use IPsec underneath as the core security engine, even when another protocol handles the connection on the surface. PPTP VPN. PPTP VPN is one of the oldest VPN protocols ever developed, introduced by Microsoft in the mid-1990s. It was designed for a time when computing power was limited, so it prioritized speed over strong security. For years, it was the standard way companies created VPN connections, largely because Windows supported it natively with no extra software. Over time, researchers found serious weaknesses in how it handled encryption, and today it is considered largely outdated and unsafe for protecting sensitive data. Some older systems still use it purely for convenience, but security professionals generally advise against it in any environment where real privacy is needed. OpenVPN. OpenVPN is an open-source VPN protocol that became one of the most trusted options in the industry because its code is publicly available for anyone to inspect and audit. That transparency matters in security, since hidden flaws are far more dangerous than known ones that can be patched. It is highly configurable, works across almost every operating system, and can run over different ports, making it difficult for network administrators or governments to detect and block. Many commercial VPN services have built their entire product on top of OpenVPN for years. Its main drawback is that setting it up manually requires some technical knowledge, though most consumer apps handle that complexity in the background. WireGuard VPN. WireGuard VPN is the newest major protocol in the field, and it was built from the ground up with simplicity and speed in mind. Its entire codebase is dramatically smaller than OpenVPN or IPsec, which means fewer places for vulnerabilities to hide and faster security audits. In terms of raw performance, WireGuard consistently outperforms older protocols, especially on mobile devices where battery life and connection switching matter. It handles moving between networks cleanly, so a connection stays stable when a phone switches from Wi-Fi to mobile data. Since its stable release, most major VPN providers have adopted it as their default protocol because the speed and security trade-off is nearly unmatched. Split Tunneling VPN. Split Tunneling VPN changes how a VPN works at a fundamental level. Normally, all traffic from a device travels through the encrypted tunnel. With split tunneling, only selected traffic is routed through the VPN, while everything else flows through the regular internet directly. A user might route work applications through the company VPN while streaming video or browsing personal sites normally, keeping bandwidth usage low and speeds high. Organizations use it to reduce load on corporate networks, and privacy-focused users configure it to protect sensitive activity without slowing down everything else on their device. Double VPN. Double VPN routes internet traffic through two separate VPN servers instead of one, encrypting it twice in the process. The first server encrypts and forwards the data to a second server in a different location, which then sends it to its final destination. This makes tracing the source significantly harder, since no single server ever sees both who the user is and where the traffic is going at the same time. It is a feature offered by a handful of privacy-focused VPN services, mainly appealing to journalists, activists, or anyone operating in environments where surveillance is a serious concern. The trade-off is reduced connection speed due to the extra routing and double encryption overhead. Obfuscated VPN. Obfuscated VPN is designed for one specific problem: getting through networks that actively block VPN traffic. Countries with heavy internet censorship often use deep packet inspection to detect and block standard VPN connections. An obfuscated VPN disguises its traffic to look like regular HTTPS web browsing, making it nearly invisible to those detection systems. It does not necessarily add stronger encryption, just better camouflage. This type became essential for users in countries like China, Iran, and Russia, where VPN usage is restricted or outright illegal. Several commercial providers built dedicated obfuscated servers specifically to keep users connected in regions where a standard VPN would be immediately detected and cut off.